wait until the weekend. You thought today was Friday. That's worse. At least I only thought it was Thursday. Right, so we have a bit more to do in integration. Last time we saw integration by parts, and then we saw volume. So I think today we're going to have a look. I'm talking here. Today we're going to have a look. Dudes, if you stop me, I'll kick you out. Right, so today we're going to have a look at, I think, partial fractions. So we're still going to continue with integration. I think it's partial fractions, although we might have to do some trigonometry before that. Anyways, let me just see now. So volume was last time, and yeah, proper partial fractions this time. So can you just write that title down, please?
Can I take your key to get the fan from the class downstairs?
Good idea, I think. Do you have that rubber you can just put underneath? We'll put it on the cap.
Oh, on the cap.
Make it higher, yeah. And push forward. There we go. More.
You have the key.
Perfect.
You have the brain.
What the hell is that?
Look, he clearly has some learning problems, okay? We shouldn't make fun of him, alright? It's not his fault, he can't help
Did you see
it.
what happened?
No, I didn't.
He took your key
Yeah?
to go downstairs to unlock the room.
Yeah?
He realized he was leaving, so this door's gonna lock on him, so he left his shoe.
Can't
Well, he has the key.
He can't help it. He just can't help it, okay? It's not his fault. We shouldn't judge him, alright? We'll just treat him differently, okay? But he's the same as everyone else. He's just
Like he's special.
yeah, exactly. Right. Proper partial fractions. So, last time, do you remember we were talking about what we do in different situations? Do you remember what you do if there's a constant over a quadratic? Remember this one?
What do we do?
To integrate a constant over a quadratic.
Use
Is the what?
denominator.
No.
No, it's the first and
The first and the second.
Yeah.
The one that has the tan in it. Linear over quadratic is probably u equal to the denominator. So in this situation we're looking at more difficult ones. We have things like linear over cubic or quadratic over cubic.
you said linear over quadratic.
It's probably, but not always, because like here for example we have linear over quadratic. So, here it doesn't work to put the u in the denominator. Anyways, what we're looking at today is proper partial fractions. So, what I want you to do as a warm-up exercise is I want you to simplify this into one fraction. I want you to put this together as one fraction. A p over a q. Oh, that key works for that there, does it? I didn't know that.
Your friend tells you to go get the fan yourself.
What?
Your friend
Yes?
tells you to go get the fan yourself.
Yeah, is this a joke or
No, I'm
a
serious.
riddle?
No.
Probably the teacher.
Yeah. Yes, that's what happened.
I'm very confused.
The other Stephen,
Yes?
he was in the class.
Oh, yes, and he said what? I hope you told him he's a jerk. What did he say?
I'll tell him next time I see him.
I don't think I said, oh, do it.
Yeah, it has.
Turn that to the left more.
Yeah, but-
Come here.
Yeah. Exactly.
Interesting.
You turn this one.
Quite interesting. Come on, Goku. Come on, Goku. Go Super Saiyan on that fan. That's not Super Saiyan.
Yeah, he's special, definitely.
No, we'll have to leave it.
No.
You're going to hurt yourself and you're going to break it.
This is not spinning.
Okay, Faisal.
Maybe it doesn't spin.
The
I'm
only
pretty sure I'm stronger than this. It's not spinning, it doesn't fit
It's
in.
okay. Give it back here. It's okay. Give it back here.
Don't give it.
Sit down, Faisal. And please give up. Right.
Don't put the needle on
It's
it.
sit down, Faisal. Sit. Great. Now, did you get an answer here yet? Good. You got an answer? Andrew, you have an answer?
Yes.
Yusuf? Great. Okay, so what did you get on the bottom? Huh? No, I want you to expand that.
Yeah, x squared.
Yeah?
Minus x minus 2.
Minus x minus 2. And on the top? 5x minus 1. So can you see that this is a linear over a quadratic? So what we're going to learn today is how we can go from here back to here. Because what you just did was this way. So we want to learn how to go backwards. Okay? Now there's a couple of ways to do this. Are you too cold? You don't feel well? Yes. Who's your tutor?
It's Ema.
Emer's not well today either. I'll tell her tomorrow. Feel better, Fawn? Okay, so as I was saying, this way you just did and backwards is what we're going to learn today. Yeah. Now, let's look at an example of how to do this. So can you write the first one down? There's two ways to do it. Actually, there's three ways to do it. I'll show you at least two. I might show you all three. In the exam, you can use either method. But we'll do this one as an example. So can you write this one down, please?
Do all 3 ways work for everything?
No.
Does one of the 3 ways work for everything?
Yes. That's why I'm not sure if I should show you the third way to do it, because it only works in very limited cases.
First one? Or the second?
No, just write the first one down and I'm going to do it. I'll show 2 ways.
So we don't need a linear over.
You'll see. I understand what you mean. Yeah, I get it. I'll talk about that. Okay, did you write that down? So, Lee, what's the question? Minus 12 over...
3x squared.
Yeah.
Plus 8x. Plus 4.
Right, so what you're trying to do is, you're trying to write this as a number over a factor, plus a number over a factor. So these two factors here, they're kind of easy to figure out because they must have been the two things that multiplied to make this. So we have two factors here, 3x and x, and I guess 2 and 2. Is that going to be it? Yeah, that's going to be it. You can use your calculator to get these. So, how can we find the A and the B? There are 2 ways to do it. Let me show you method 1. Method 1 is you multiply everything by these 2 terms. So you have minus 12 times 3x plus 2, x plus 2, over 3x squared plus 8x plus 4 equals A over 3x plus 2, 3x plus 2, x plus 2, plus B, 3x plus 2, x plus 2 over x plus 2. Now what cancels on the left?
The brackets and the denominator.
Both of these cancel with that. Here, this cancels, and here, this cancels. So you're left with minus 12 equals A, x plus 2, plus B, 3x plus 2. Now this is method 1, but the only difference between method 1 and 2 is what you do on the next step. Okay, so what I'll do is, can I scroll down? I'm going to split this problem into halves. This is method 1 and this is the second method. Okay, so the first method is you expand. This method I like because it works in most situations, as does the second method. Both are quite good here. So minus 12 equals ax plus 2a plus 3bx plus 2b. So minus 12 equals a plus 3b x plus 2a plus 2b. Is that okay so far? So on the left you have 0 x's plus minus 12 equals a plus 3b x plus 2a plus 2b. Now the reason I wrote it like that is because technically what this is not an equation, it's called an identity, and you represent an identity with 3 lines. Does anyone know the difference between an identity and an equation? No? It's a new thing? You know the difference?
I know them. I think the equation is you have two sides and you can move them around. An identity, this is the same as this, but you can't move them around.
It's an equation.
Almost.
And the coefficient of this x with this is the same as
Yeah,
this
it's
with
a
this.
comparison.
Yeah.
But it's a bit more than just that.
Yeah, obviously.
The difference is this is an equation. Because you can solve it. What's x here? 1. This is an identity. You can't solve for x, it's just a statement of algebra. So this is technically an identity because you can't solve for x, it's just a statement of algebra. But you can make a comparison. So if this is linear and this is linear, then as Faisal was saying, the coefficients should be the same. So we have no x's on the left, meaning we should have no x's on the right. So that means a plus 3b equals 0. And likewise, 2a plus 2b should equal minus 12. So this is pretty easy to solve. 2a minus a. Oh no, sorry, I should do some multiplication. You know what? I'll divide this by 2. A, b, 6. Okay, so a minus a is gone. That's 2b equals minus 6. So b equals minus 3. Yes?
No, 6 not minus 6.
How did that become? No, it was minus 6.
So it becomes
Because it was
6.
minus 12.
Yeah, so it becomes 6.
No.
Yeah.
Hold on. Dude. Dude. 6, thank you. B equals 3.
Yeah.
So if B equals 3, that means A equals
Minus 9.
minus 9. So we have our A and our B.
Yeah.
Now, let me show you the second method. It's much quicker than this method. So what you do is, again, taking it from here, you say, well, this isn't an equation, this is an identity. That means this is true for all x. Example. This is true no matter what value of x I use. For example, if I pick any random number like 5, it is true to say 5 plus 5 is the same thing as 2 times 5. The value of x is not important. So likewise, if this is an identity, it's true for all x. So it's true when x equals minus 2. And he said, why did I pick minus 2? Well, if I pick minus 2, I get minus 12 equals minus 4b. So b equals 3. And it's also true when x equals minus 2 over 3. Which means you get minus 12 is equal to a times 4 over 3, right? Which means that A will equal minus 9. So you get the same answer. So we have two methods here. Both of these methods I like. The second method's a little bit quicker, but there is something I don't like about the second method. And I wonder if anyone knows what it is I don't like about the second method.
When it's an equation,
No, I'm cool with that.
you're guessing.
Huh?
You're guessing.
Not really,
No.
because in my head I'm just making this equal to 0, so it's okay. Anybody?
I remember that we learned both, but I always used this.
Which,
Then
one or
used
two?
This one, no, I used one all the time. Until when I got really stuck, then changed to two.
That's normal.
But why the reason? I don't really know why the reason. Whoa.
Could you explain that part?
No, I'm waiting for a reason why I don't like the second method. Go on. You're halfway there. Come on, you're so close. No, you're so close.
If we don't have a linear, we can't use it? Or if we don't have...
No, it works for quadratics too.
No, I mean, if we don't have an
One
x,
x is a plus one.
or if we have one x.
No. The reason I don't like it is because the values you use are the values that are forbidden. X can't be minus 2 here, why not?
Because you get a 0 on the denominator.
This is actually quite bad. I should not be using these values of x. I really shouldn't. However, it works for these types of problems.
Rebel.
I am a rebel. And it works for these types of problems.
What do you mean, like negative? How would
Give me a full sentence.
How would the negative affect? Like when x.
No, I just said I shouldn't be using x equals minus 2 because it will make that 0. I shouldn't divide by 0. You understand?
Yeah.
What?
But then it works for everything?
Yeah. Yeah, I can't think of a problem where this doesn't work.
What about the first one?
Same works for all of them.
Could you explain that?
Yeah.
As a plus 3b equals to 0.
Yeah. What I did was, on the left I have 0x, and on the right I have this many x's. But they should be the same. So it must be the case that a plus 3b is 0. Likewise, I have a minus 12 on the left as a constant, and I have this on the right as a constant, and they should be the same. So what you're doing is you're comparing. Yeah. Faisal and Omar and Wong.
He's the victim.
Huh?
He's the victim.
Okay, fine. Faisal and Omar, be good, please.
He's the victim too.
I'm not surprised by this. Yeah. I'll show you the third method in a moment, but please note, these first two methods should work for all problems. The third method, although the quickest and easiest, works for a very limited number of problems. In fact, it really only works with exactly this type of problem. But sometimes you get this type of problem in section A as a quick question. So this method I'm about to show you will be suitable. Please write this down.
Yes.
Yes.
Could you line up?
Huh?
Yeah.
Oh, okay. Is this enough or more? Yeah. Stephen Bruce downstairs. Got a text him saying I hope he's not too hot in the classroom.
Are you guys jealous of each other because you have the same name?
He's jealous of me.
That's what you all say.
My goodness, you guys are pushovers. It's too hot, I'm sleepy. It's too cold, I'm sleepy. The temperature's just right, I'm sleepy.
Can you do this?
No, and I feel so incomplete in my life that I can't.
Can you do this, Andy?
Not quite, not quite. Can you do this?
So hard, so difficult.
No, try, do this. Work on your silent skill. Thank you. Right, did you write these two down? Yes. You did? Okay.
No.
Oh, come on.
Bro, I have two different flavors from my two different boxes, so play yours.
Do you have any with you now?
Yeah.
Cough one up.
If they sponsor you,
Yeah, I want to see you wearing a Tesco shirt next time you're in here.
You took my savings biscuit from last night.
What? Oh, yes. Well, you know, life sucks like that.
And you gave me a C. I take not.
So are you talking? Okay, do you have that now? Yes? Okay. Third method. And please, this third method is coming with a warning. It only works for these types of problems. Exactly this type, where you have a constant over a quadratic. It works as well for linear over quadratic, but I'll talk more about why and how it works when I do it now. Okay.
No.
Faisal, please.
Stop talking.
Faisal, please. No, sorry. You leave it blank, and then you write 3x plus 2, and another blank, and then x plus 2. Okay, and what did I get for a? I want to make sure I get the same answer. Minus 9. Okay, where's it gone? Here it is. Okay, so this is method 3. Now, can I just borrow the calculator? I just want to check that it works here before I do it. Hang on. Oh my goodness. What were my answers for A and B?
Minus 9 and 3.
Minus 9 and 3. Yeah. Okay, so this is what you do. Guys, watch carefully, please. This is what you do. You write the two factors here underneath. 3x plus 2 and then x plus 2. And if you want this number here, let me see, you look at this and you say, how can I make this 0? So what value of x makes this 0? Minus 2. And you put minus 2 into this fraction. So, let me just write that again here. I'll just write this like this. Okay, and how do we make this piece here 0? You make x equal to minus 2. So you put minus 2 in here for x. And if you put minus 2 in, check what you get. Minus 12 over this with a minus 2 for x. Check, please, on the calculator. Oh, sorry, that gives me the other one then. You got 3?
Yes.
Yeah. Okay, so if you want the first one, yes, okay. So I was looking at this to make it 0, so I was getting this one here, 3. Alright, next. If I want this one, I look at how to make this 0. So what value of x do you use here? Minus 2 over 3. So if you put minus 2 over 3 into this fraction, check what you get.
We put minus
Why,
2
that's
there,
nine.
right?
Minus 2 over 3 into this one.
No, minus 2. What? The first one.
Oh, I'll do it again. Now watch, I'll only say this one more time. Wrong, you are not the victim this time, be good. Watch. If I want this one, I look at this, and I match it up here. What value do I choose for x to make this 0? This piece here 0. Minus 2 over 3. So I put minus 2 over 3 into this fraction here. And that will give me the number that goes on the top here. Take out the calculator that is right in front of you, type this fraction in red, and then replace the x with minus 2 over 3. And you do the same thing here, and you get 3. Now this method is called the cover up rule.
Yeah.
That's what we do, minus 9.
Because you cover the one.
You cover this up and put the value in here. Okay. Now, when does this method work? This method works when you have a situation like this. You have an A over a linear plus a B over a linear. That's the only time it works. And also, I should say that these linears need to be different, of course. So it's a very limited number of cases when you can use the cover-up rule, and this is why I don't usually use it. Now we'll have a look at more difficult problems now in a moment. I just want to give you a quick one to try. Did you write this method down?
Could you just go back to method 2? I'll just take a picture.
Go back to what?
Method 2.
Okay. Okay, so what I want people to do before I do a more difficult one is I want you to do B, and you can use any method you want, I believe, in B, and then I am going to do as a harder one something with the cubic in it. So please try B now. You're doing the question. No, you're still awake. Finished? No. finished it? We've lost Yusuf. Hang in there, Yusuf. Did you finish it? You got the A and the B? Had a quick nap?
Yeah.
Is it the fan that's making me sleepy?
Yes.
How?
That's always the problem.
It's too relaxing, isn't it?
Yes.
Alright, we'll turn it off for a few minutes. I forget you're a minor, you're quite young, so I understand, yes. Come on, guys, this is taking forever. What's the A? You got the A and the B? Yeah. Which method did you go for? 1, 2, 3? Yusuf?
First.
Lee? Got an answer? What you got? 2 and? Got the same? Yusuf? 1? Oh, come on, hurry up. I want to do a harder one.
Can you go back to your working? I want to ask you if I can not show a step.
Which method?
The first one.
Yes?
The first step, not the first method. Can I not show that the denominator is the same and then cancel out and then...
Yeah,
Go
later.
for the identity.
Yeah, yeah. You can
That's
go.
fine?
Yeah, because you do so many of these, you can quickly jump to it. Yeah. Come on, folks. Do we have an answer?
For which one?
The one you're doing.
I'm doing both.
Okay, fine. Do we have an answer, Wong? Yeah.
Yeah, I got 2 and I'm looking for the other.
If the denominator is
I go minus 8.
That's what I'm going to do next, but go on.
we could use method 3.
Yes, provided that you have, again, 3 linear distinct denominators, which doesn't usually happen in the exam. The first example I'm going to do does. I'm talking to Andrew. So to answer your question, it will work, but in real life, in the exam, you'll find that you can only really use this third method if you get a question on this in section A. It's quite short. So I kind of stay away from the third method most of the time. Faisal, what do you want? No, yeah, not maybe it wasn't
yes.
important, it definitely wasn't important. Yes.
The book.
Book?
The one I emailed you about.
I told you, the printer's not working.
So this is next week.
Is this next week? It still feels like the same week. Okay, if it is, if this week really is next week, I'll bring it to class tomorrow. But if this week is still this week, it has to wait till next week. Until
How will you find out?
I will go back to the office, I'll do some deep meditation, I'll recall my memory, and then I'll decide.
You just tell me.
I know I'll use deep meditation candles and sure, I might even draw a pentagram on the ground. I don't know. We'll see how I feel. Okay. Wong, you got an answer? What you got? Super. Yusuf? Great. Okay, so this is fine. Let's have a look at something more difficult. I'm going to do this cubic one now. E, can you just write it down, please? And I'll do it.
You're not going to do that one?
Which one?
The one you told us to do?
Do.
How's the O will be the same difficulty as E.
Yeah, but because I did O, so.
And this is why I'm doing E. I'm not doing it because the other people got it, but I am going to do this one, which will be similar and harder. Did you have trouble getting the answer previously?
Yeah.
What did you get?
I got the two equations and it was -10.
It sounds like you could have just made a small slip. I can check for you where it is. Okay, did you write that down? E, please. Sorry, not E. E, yeah. Not as good as the original, sorry. It doesn't have enough, you know. Okay, can I do it now to write it down? Alright, so, read it back to me. What is it? -12 over...
No. -478.
-478.
X -370.
370.
Over 189x cubed.
Yep,
Plus 663x squared.
yep,
Plus 566x.
yep.
Plus 112.
Right. If we look at this one, I will just do a quick mode 54. To get the roots. It distracted me. So, the first one is 3x plus 7.
9x plus 2.
What's the next one?
9x plus 2.
Okay.
9x plus 6.
Now, isn't it? 7x plus 2.
Yeah, my son looks like
9x plus 8. Fine. Now, you can actually use all three methods here. Did anybody use the cover-up method? Method 3. You use method 3. Yusuf, you use method... Yeah, 1. 1. Omar? 3. Okay, Yahya? In the previous one, I mean to say, sorry. This method here, we can actually use any method. I think I will go with my favorite, which is method 2. So I'll multiply everything by the 3 terms on the right, these 3 here.
Wait, how do you know if G is applicable to?
Yeah, how do you know? When you have 2 or more linear denominators that are different, you can use this method. Now, I'm going to really emphasize that 2 or more linear denominators that are different. This is only when you can use it. Okay? And the tops need to be constants, obviously, because that's what this method gives you. It gives you a constant. Okay. Now, if I use method 2, I end up with minus 478x minus 370 equals A times 7x plus 2, 9x plus 8, plus B, 3x plus 7, 9x plus 8, plus C, 3x plus 7, 7x plus 2. Okie dokie? Right. So if I want to find A, I choose what for X? What can I choose for X to find A? 0? No way, man. Not even close.
For A,
Yeah.
minus 7 over 3.
Because it will cancel the B's and the C's, leaving with just the A term here. If I want to find B, what can I choose for X here? No, not minus A over 9, because that will cancel B. Correct. And finally, to find C, what do I choose? Yeah, minus 8 over 9. And then I can find my ABC, which I'm not going to do because that's trivial. But I can also use the cover-up method as well, which works perfectly fine. So let me just grab out my calculator here. Right, so using the cover-up method, let's get the A first. So if I look at the A, how do I make the denominator 0 here? What do I use for X? What do I use for X to make this 0? Minus 7 over 3. So I have minus 478 times minus fraction 7 over 3 minus 370 over, and then I have the other two terms, 7x plus 2, 7x plus 2, and then the next one is 9x plus 8. So this here is minus 7 over 3, and this one here is minus 7 over 3. I think I typed in something wrong.
The first one is 4, I got.
For A? Good man. What did I type in wrong here though? 7x plus 2, 9x plus 8.
You multiply the minus 7. It's supposed to be 478 times minus 7 over.
Oh, very good, thank you. I don't have my bracket in the right spot. Should be like this, huh? What did you get for A, Omar?
4,
And which method did you use?
7.
A different method. Nice. Let's see if we get the same answer for this method. Ding. And if you were to choose this value of X and put in here, you'll also get the correct value of A. So all three methods work here to give us the same answer. That's great. Now I'm going to give you one to try now that's like this one here. Let's see what happens. So let me just check something here. Can you try C for a moment? It's actually, I don't want to give you a cubic just yet, but something strange happens in C I want you to try. Omar and Juan, you can work together, but I want you doing C. Correct. I know, it seems simple, doesn't it? You're thinking, why is he asking me to do C? There must be some trick to it, a catch. And do you know something? You're right. Yeah. Now see that face there? He's spotted with a problem. What's the problem, Yusuf?
Only have one root.
Exactly. Quite interesting.
I know this.
Do you?
Yes.
Are you sure?
AX plus B
Possibly.
over the root.
What's the term?
Do AX plus B over that one root and then continue so.
No.
Do it. If you don't get the answer, you can cut all my fingers.
You still owe me $1 million. Oh no, that's you actually. Right. Now, when you try to find the roots, you discover was the root.
That's not the,
That's
What?
that's the question. It's x squared minus 10x plus
Oh, I was distracted. X squared.
minus 10x
by the green, no, that.
plus 1.
Okay. What is the root?
X plus 5.
X minus 5. And the other root you discover is also x minus 5. Now, it is totally wrong to write this. Totally wrong.
X plus 5.
No.
No, minus.
Tell me why this is quite wrong.
Because they're the same denominator.
Wait! You talk quite enough. Go ahead, Andrew.
They're the same denominator, which
Yes?
We can just add them up.
Yes?
a plus b over x minus
Yes, you can just say that's a plus b over x minus 5. And a plus b is just the same as like a c. And there's no way on earth that this could ever be this. They're two different.
So it's squared. No?
No.
Possibly. Let's see. So, you actually have two ways to proceed in this situation. Believe it or not, in this situation, the second root will be x minus 5, and Yusuf, you were pretty close there, squared on this one. And on the top here would be a b. And you might be thinking, will this not make the denominator cubic? And it doesn't.
And this is
Yeah. Will it not make the denominator cubic? Why not? Will it? Will it not?
It will cancel out.
Will it make the denominator cubic or not?
It shouldn't.
Now you see, the way you said that, you're not so sure though. Yeah, go on. The denominator is not cubic because to add these together you just have to multiply the top here by x minus 5 and the bottom here by x minus 5, making the bottom a quadratic, exactly the same as this, and the top a linear. Anyways, this raises the question of how can we know what to write on the right, especially when we have a situation like this. So I'm going to give you some guidelines on what to do in different situations before I continue. So, I'll do this one in a moment, but first, guidelines. Okay, so the first thing is, you have a P over a Q, and you try to write it, if you can, as a linear plus a linear plus a linear, etc. As many as you need. And these are all constants. So this is what you try to do first. But that's not always possible. You want these to all be different. For example, there are some situations where you don't get a linear. You get a quadratic. So for example, you have a over a linear plus, and then it's impossible to get a linear. We'll get a quadratic here. It's impossible to get a linear. So then the question is, what do you write on the top? And it's not actually b, it's something else. And then the third situation which we need to have a look at is what happens if, when you try to write the two linears, what do you do if these are the same, which is what we actually have in this problem. So, these are the three different problems you come across. This one is the nicest. The first one is the only case you can use the cover-up rule. when you have what you want, not in case 2 and 3. So my guidelines are, in this case here, the top then needs to be a linear, like, for example, bx plus c. So the idea is, here is the bottom, here is the top, and the top should be 1 power less than the bottom. This is one of my guidelines. So for example, if the bottom is linear, then what's before linear? Constant on the top. If the bottom is a quadratic, then linear. And if it's a cubic, then the top is a quadratic, obviously. Okay, so that's one guideline. So that takes care of number 2. So then what do you do in cases where it repeats, like in number 3? Well, the guideline here is, if you have something that repeats, like for example, I don't know, a over p, and then the next one is also the same, of course you don't use it. Instead you have a over p plus, you square it. Now think about this for a moment. If p is linear, then what is p squared? A quadratic. So what should go on the top here? A linear, which is bx plus c. However, there is a third guideline here which is quite useful. So if I can scroll down for the moment. Here I gave you the rule that the top should be 1 power less than the bottom. Yes? But there's another rule here that says you have constants on the top and constants on the bottom. And again, the top should be 1 less. So what do I mean by that? Let me show you over here with an example. So for example, if you have something like 2x plus 3 squared here, and the top is bx plus c, because the bottom is quadratic and the top is linear, seems okay. But how many constants do I have in the bottom here? How many constants? How many coefficients? 2. What are they? 2 and 3. So how many should I have on the top? 1. And how many do I have? 2. So this is the great thing. You are free to make one of them 0. Now, in fact, you don't have to do that. You could keep B and C there, and that's fine, but you've made the problem a little harder. So you're free to make one of them 0. So now, returning back to the question, you have 2 ways to proceed. You can say this is A, well actually you have 3 ways to proceed. You can have A over x minus 5 plus bx plus c over x minus 5 squared, or you can say this is equal to A over x minus 5 plus bx over x minus 5 squared, or you can say this is A over x minus 5 plus c over x minus 5 squared. So obviously there's one we don't go with. Which choice do we not pick? No, the first one. Why don't I pick the first one? Yeah, because I have to find A, B and C. Whereas here I only have to find A and B, or here I have to find A and C. Okay. So what I want you to do now, I'm going to split the class into halves, and I want one half to do this problem and the other half to do this problem. So we'll go with Andrew, Yusuf, and Wong.
Huh?
Wong? Yeah. Sorry, that was just me slurring my consonants. And Wong, if you can do this one. And then Omar, Faisal and Yahya, can you go the second one? No, but the same level of difficulty. Fine. Yahya, Yusuf, and Andrew, you do this, the first. First one here.
Yahya won.
Hang on, here's for.
Oh.
Right, it is all because of Faisal. Sorry. Shh, wait.
Again.
You
Yeah.
and Faisal do the first one.
Okay.
Everyone else do the second one.
Can we use Lee's?
No, Lee's sleeping now.
Lee's too gone.
He's, look at him, he's fast asleep.
I like him.
No, don't, leave him. He'll be cranky, leave him. That's a deep sleep. Right, try this one.
He's probably dreaming about this anyway.
He's now singing of anime songs. Complete the lyric. Faisal, complete the lyric. I want to be the very best.
Let no one ever know.
Yeah. I could count on you to finish that, I knew it.
Anytime.
Did you try the game that everyone was so crazy about, Pokemon Go?
I won't get into it. I'm sorry. Yeah, hang on, let me just go to the App Store here. No, I'm sorry, I'm old school red and blue.
Only place the copy.
Did you get an answer for A and B?
No, I don't know what to do.
They
You
are-
cannot use magic tree. Huh? What you got for B? A and B?
I do A.
Oh, is that the one you're doing? Yeah, okay. Did you get A and C yet? Did you not get A and B? Come on, try.
How can I get rid of the denominator on the left?
No, you need to multiply everything by x minus 5 squared.
X minus. Oh, yeah. 5.
Squared. Good morning. We are doing this question now. I've asked the class to find AB and AC. I would like you to find AB, please. Now that you're rested, there should be no problem. Now I should tell you, I usually spend a double class on this topic because it's quite new and difficult, because I haven't even done more complicated cubic ones yet, which I want to do next. Do you have an answer for A and B? Right outside Jet. Who else is getting A and B? Andrew? Okay. Are you getting A? Okay.
Where's the B in this one? In the third one.
There isn't one.
So it's A and C?
Yeah. Is that the one you're doing?
No, I'm doing so.
Okay. Okay. Do you have an answer, Yusuf? Wong? Which one did you get? A and C. Who's getting A and B? Did you get A and B? What did you get for A?
And B
Is that what you got?
minus 8 over 5.
Minus 8 over 5. Yes. Okay. No. Let's have a look. So, what did you get for A? Minus.
Couldn't do it. Like I couldn't do it.
Okay,
He
Lee.
basically got the same values.
Okay, Lee. What's A?
Minus 4.4.
Okay, minus 4.4. Over x minus 5 plus, and what you get for B?
Minus 150.
Right. So that's what those guys got. Okay, now watch this. I'm going to just simplify this. And I get this, which is 22 minus 6x, which is what we have. Nice. Now, people who were getting the A and the C, I want you to give me the A, please. What did you get? Say again? Minus 6 and minus 12. Now, if you look at this and you look at this, they're quite different. But yet, when I simplify it, it's wrong, which means you guys made the mistake. Guys, what did you get? Minus 6 and minus 12? Who else was getting A and C? Faisal? No.
No.
Huh?
What?
Guys, how'd you screw this up? What's the A and C?
I only know the calculation. The rest is okay.
Guys, Faisal, you were doing the first one, were you?
Yeah.
So who was doing the second one, getting the A and the C? Yahya, Juan, Omar?
Just wait for this one.
Okay guys, other half of the class needs to pick up the slack for that half of the class. Can you recalculate the A and the C for those guys? They're having trouble. Is it possible that you just got it backwards? Let's see. No.
Shame on you guys.
Yeah, you're not exactly in a great position yourself. I want you to get the A and the C.
So x
C is minus 8.
Correct.
C is minus 8.
And A is minus 6.
Yeah, of course.
So as I was trying to say a moment ago, these two forms look quite different. Yet when you simplify them down, you get the same answer. Meaning that although they look quite different,
So there are a couple of answers.
there are two answers here. In the exam, they will tell you which answer they want, or they won't care which answer they get. They'll never ask you for both answers. Okay, so you have two here. Alright, let me see. I want you to try... Okay. Can you try H, please? And you can use your calculator to find the roots of the cubic.
using math error
For what?
for the equations that I got.
The linear?
The one we were solving.
What do you mean math error? What were you trying to solve on the calculator?
I'm using the identities for x square, x, and no x.
Oh, and yeah, and you made 3 linears?
I made 3 linear equations, yeah,
Yeah.
and it's not working on the
That
calculator.
means that the 3 equations do not have a solution, which means this method doesn't work.
I was using the first one, the bx plus c.
Yeah. Correct. I just said you made it much harder if you go it that way. So the method doesn't work for that because what's happening is you cannot form 3 independent equations find A, B and C. So that is because you need to know the fact that one of the B's and C's is a 0. Now it's still not impossible to solve, but I believe you'll have to use a mixture of method 1 and 2, use them together to try and solve for A, B and C. But you will discover, if you do it this way successfully, that one of the B's and the C's are 0, but you may not even get an answer because which one is 0 is your choice. So the equation you might have to do something to form a quadratic where you have 2 answers for B, one of them 0 and the other one's not. So you've just made things like 10 times more difficult. I don't believe it's impossible, but just much more difficult.
When the calculator gives us the roots, which one is repeated? Which one is
Excellent question.
Yeah.
Excellent question.
You can't do the second question.
Let me show you how to decide.
You can't find out.
So can you give, what's that?
You can't know which one is repeated.
Yes. Yes, he can.
Not on the calculator.
Yes. By using a little bit of his brain and looking, he can.
Yeah, but like not when the first. It's not like the first one on the second.
No. But anyways, please be quiet. What is the cubic, Yusuf?
28 x cubed
Yeah.
plus 36 x squared
Yeah.
plus 15x plus 2.
And the factors?
X, 7x plus 2 and 2x plus 1. Yeah.
Now, there is a very simple way to figure out which one is repeated. Anybody know?
Use one of the values.
Huh? Say again? No.
How do you get the x cubed?
Yeah.
How do I get the x cubed?
The 28.
7 times
How do you
4,
get?
so
28x cubed was in the question.
They
It's
mean
it's the 2x
There's
plus
something
1.
missing here.
Just what's that?
It's 2x plus 1.
Yeah. How
you have to square one of them to multiply with the other to
Yeah.
get the 28.
Which one?
The 2x
The
plus 1.
2 square to get a 4.
You're gonna get 7 squared.
So 4.
No, because
7x plus 2x.
Yeah.
Times the-
these 3 must multiply to make this.
Yeah.
So it has to be this because if you had 7x plus 2, you get the wrong number. I usually look at the back though. I needed 2 at the back. So 2 times 1 is already 2, so the next one must be 1. Right, so this is how you can know which one's repeated. Okay, keep going.
So we can use the third method for this.
No!
But you were like,
What did I say? I said you
Yeah,
can use the
only
third
when-
method. Yeah?
only when we have 2
Yeah.
or more linear denominators and we have 2.
Yeah, but no, you have 3 because your denominators are 7x plus 2, right? 2x plus 1, and what's the third denominator?
It's the same, but then that's 2.
No, it's not the same. It's this one squared.
We're doing h.
No, sorry, what did I just ask you? Yeah, h. Yeah. You have 3, you only have 2 linears and one of them's a quadratic, so you can't use the third method. You finished, Faisal?
Can you repeat the first one?
What did you do?
Oh, yes. Can you-
For what?
The first one, but-
For A?
yeah, okay.
You got B?
But- Just look at it.
You got it? And what did you choose when the root was repeated for the top? Because you have three terms, right? The first one was what? A over 7x plus 2?
First one. No. With the X you mean?
No, and just, yeah, what were your three denominators? 7x
2x plus 2 and 2x plus 1 squared.
and 2x plus 1 by itself? Or
No,
did you,
squared?
you only had 2?
Yeah.
Ah, no, 3.
2x plus 1 and 2x plus 1
Do you
squared.
have two pieces
Yes,
of
yes.
chalk or one?
There's three different 7x plus 2 and then 2x plus 1 and then 2x plus 1 squared. A, B, C.
Correct.
Is the same as the last one?
Yeah, and in the last one we had the linear and the linear squared.
7. You got 7 for me?
Omar, what were your three denominators?
4, 7, 7.
No, the three denominators. Guys, you were supposed to do this. And you can have A, B, and this one you can choose either CX or just C.
Oh, why is it CX?
Because,
use B again.
well, yeah, but you mean why is there an X here?
Yeah.
Because if this is quadratic, the top can be linear. Did anybody do it this way?
Yes.
Oh, good. That's okay. This is why I give it a double class, because they're hard. Yusuf, is this okay now?
So, if we're using the first method, we put the first equation, we put the fractions in the first equation on the numerator, and then we cancel them with the denominator.
Yeah. You'd multiply both sides here by the three factors. Now I know one of them is repeated, but that's okay.
And then we take, for these, like to cancel the denominators,
Yeah.
we just take the denominators from
They should cancel at the top. Yeah.
So we just take the two, both of them? Like as in
Yeah,
the
no,
denominator-
use the square when you multiply.
No, as in the denominator
Yeah.
of
Oh yeah,
B
you want,
and C
yeah.
for A. Like A equals A times the denominator of B times the denominator.
oh, you mean the quick way of doing it? It'll end up being A times the denominator of,
B.
no, it's not going to be quite like that, because what's going to happen is you're going to have something over something equals A over that thing plus B over that thing plus c over that thing. I'm not going to rewrite it. Can you just imagine that they were there?
Yeah.
Yeah, so what you do is you multiply by the 7x plus 2, the 2x plus 1, and the 2x plus 1.
Yeah.
So those three cancel the cubic here. But what happens here, the 7x plus 2 cancels the 7x plus 2.
Yeah.
And then here, one of these cancels one of these.
Yeah.
So you're left with two of them. And then here,
Two of them.
two of them cancel that one there because there's two of them here. It's a square.
So only that one cancels, but 2x plus 1 is there.
Yeah, here there's 7x plus 2. Here there's 7x plus 2 and 2x plus 1. And here there's 2x plus 1 squared.
So for C, is
Yeah.
Also, yeah,
C
this makes
times
sense.
7x
Yes.
plus 2 times...
No, because these
Plus
two,
plus
no, these two cancel this. Because on the bottom is two of them.
Yeah.
On the bottom is 2x plus 1 and 2x plus
Yeah, what
1.
he's saying is right. C times 7x plus 2.
No, you then
No.
continue to say multiplied by.
Also,
Yeah,
8
but
times
what I mean is, isn't that one of the factors, like 2x plus 1 squared?
No,
Like why?
no, the factors are 7x plus 2, 2x plus 1, 2x plus 1. They're the three factors. It just happens that two of them are the same, which we can write as a square. But it's not, don't think of this as a factor. You should still think of it as three factors.
I don't know why.
Even though it's repeated, it's better in your brain to think of them still as three factors. So, I think this is the confusion. Okay, it's still three. Right, is this okay? Is this okay? Yeah.
Because why is the denominator square? The one the
Why is it squared? But I explained that, like, it's like, I explained that like 15 minutes ago.
really?
I did. I even wrote the explanation down over here.
Yeah, this square.
You must have not been listening.
I was focused on
Okay, you might have to watch the video. I'm not going to repeat myself. I'm sorry because I need to press forward. No, thank you.
Wow, what has happened?
I'm trying to get one more question done.
you want.
I would like you now to do I. This will be the last one we'll do. Okay?
Me?
Faisal, do I. Gimme. Do I. Are you going to do I?
Yeah.
Do it quickly and quietly.
Could you tell me what happens after?
No, you don't need to come up. Just hand me the book. Let me just see what to do next. This is I.
No, it's F.
All right, come over then. Watch the wire. Watch the wire. It's not the TV show.
Because
That
I
is.
was J.
What?
I.
Do I? Yes.
I did J.
Do what I ask you to do, not what I don't ask you to do. What to do next?
Was you?
Right. I don't know what's going on here, so I'm just going to scratch it out. You are multiplying everything by the three factors. The
Yeah.
three factors are the 7x plus 2, I'll just write 7 for short, the 2x plus 1, and the 2x plus 1. So those three factors go on everything.
Like in the house, my house.
Yeah, so those three cancel all of that.
Yeah.
The 7 cancels the 7.
Yeah.
The 2 cancels the 2. And both of these cancel this.
Yeah.
Yeah.
After that, like when we were finding the ABC.
So you get 16x squared plus 65x plus 18 equals a times the two factors
Yeah.
plus b times the two factors plus c times x times one of the
You
factors.
can manage for it.
Yeah.
So what's the problem?
That's
And then you make them into
Then you-
simultaneous
yes.
equations.
Yes, three simultaneous equations. Yes, very good. So you expand this and then you compare and you say something here equals 16 and then 65 and then 18.
Yeah, but here.
Yeah, it didn't work.
No, like I have an A and a B,
No, but you didn't put these.
Oh, yeah. These are wrong practice.
Okay, so
They're wrong.
but it doesn't matter if this is wrong. This is wrong because here you have a plus bx. Can you see that?
Isn't it this and like you were like
No. I put the x's together to make a plus bx. How many x's do I have here?
okay
A plus b.
yeah.
A plus b should be minus 22. Is this the problem?
Yeah.
Oh.
Yes.
What do we do?
What?
What do we do?
Good question.
What?
Long division.
Dude, my life is more interesting. Finish it.
Yeah.
No problem.
Yeah, that's how it goes.
How many days do I have?
What about?
How many days do I have? Only one. Finish it. You know what your friend said today?
Who's Stephen Bruce? He's not my friend, but go on.
He said, I don't know why I'm a boy or a man.
What? No.
Yeah.
No.
Yes.
No, he wasn't saying that. He was
Yes, they were talking about the X and Y, and then he said, I don't know why I'm a man. And then I said that.
He wants to know why he's a man. Like,
No, he
But
said,
the
"I don't
real
know."
question is he a man?
But no, he was talking about a chromosome.
Yeah, but something I can't follow.
Man and woman is like negative and positive, yeah.
I know.
So you can say negative is positive.
What?
Lee, you are dangerous.
What is it?
I really don't know what's going on right now. Right. Have you all discovered the problem in I? What's the problem here?
He needs to know
The root.
Yeah. So, can you just read out the question, please? Faisal! Read out the question, please.
6x squared plus 15x plus 45 over minus 3x cubed
Yes.
minus 13x squared minus 28
13.
Oh, sorry, his singing is a bit distracting. Minus 13x squared, yeah?
minus 28 minus 8.
Beautiful. Now, when you looked for the factors, what did you get for the cubic? The first factor is 3x plus 1. So here is A. And what are the other factors? Hey, there aren't any other factors, there's only the 1. So how do you find the other factor? Nope. Long division. So if I just open up my program here, to be pig lazy, you did it the honest way. Good for you. You seem like an honest guy. Divided by what quadratic did you get? Let's see if you're right. Yeah, but what quadratic did you get?
Minus x squared minus 4x minus 8.
Did I type this in wrong? Oh, I did, sorry. That should have been at 13. Okay. You got this? Yes? So, the other factor is minus x squared minus 4x minus 8. So what do we put on the top here?
Bx.
Yes. Bx plus c. Yeah.
Question. Why did you do the bx plus c here, not make one of them 0?
Again, just like I said to Wong, I explained this 20 minutes ago.
No.
Yes. Yes, I explained it all here. I have 3 different scenarios and then what to do.
Yes. You said we can use, we make one of them
Now you see,
0.
this is your problem. You don't listen to me because you're all blah 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 blah
No,
blah.
I listened.
Yeah, no, you didn't listen to me. So I'll explain it again. Wrong. I'll explain it again. I said the top should be 1 power less than the bottom. So if it's a quadratic, the top should be linear.
Yes.
I also said the number of coefficients on the top should be 1 less than what's on the bottom. So, therefore, here, what have I got on the bottom? A quadratic. So what should I have on the top? A linear. How many coefficients do I have on the bottom? 3. So on the top I should have 2.
Duh.
Yeah. Duh. Right. And we cannot use the third method. I think what method works quite nice here is the second method. However, you'll notice a small problem at the end, but it's not really a big problem. Guys, look, I won't fully do it because it's not difficult, but I just want to highlight the problem that arises. When you multiply by the cubic, you get this. And then 3x plus 1. So your first choice is quite clear. What do you choose first for x? Well, you could choose minus 1 over 3, and what does this give you? It gives you a. What to choose next, though?
Substitute the value of a, then expand.
Yeah, but what do you choose next, though, for x?
Any value.
No. 0. Yeah. And you should use the value you got for a previously, because if you think about it, if x is 0, you know this, you know this, you know this, and if you use a, you know this, you know this, you know this, you know this, and if you use 0, this is gone, and you know this and know this. So what will this give you? It gives you c. But how to finally get the b? What do you do?
Substitute everything
Substitute everything and
don't make the x 0.
yeah, make the x what?
Any negative number.
Any number at all except the ones used previously. So for example, if you use x equals 1 and use a and use c, then you know this, and this, and this, and this. And if you use x as 1, then that just gives you b here, so then this gives you b. So it's a little bit harder than what we did, but not much harder. And this is a typical exam question. This one is a typical section B question. In fact, it's actually a little bit easier because the next lesson is harder, which is what we're going to do. More of these, but harder. And then we integrate them. Yeah. So later we'll integrate this. Oh yeah. Yeah. And you know, this is where in the TV show it will just go and end. So we'll wrap it up there.